Today we are going to talk about long division and synthetic division. Before we get into showing long division of polynomials, I actually want to go back to what you learned in elementary school and show how what you did back there is actually showing up again when we're doing long division. Okay, first thing I want to do is I want us to list the factors of 42. So when we list the factors, we write it as 1, 2, 3, 6, 7, 14, 21, and 42. Okay, the reason why I wanted you to write this list of factors is because I want us to understand that term factor. So when we say it's a factor, what does that mean? Okay, well, it means two things. It means that the factors divide evenly into 42, meaning that they have a remainder of 0. So if I do 6 divided into 42, that gives me 7. It divides evenly, therefore it is a factor. Okay, and then when the factors are multiplied together, they give us the original value. Let's go ahead and take a look at dividing using the long way of division, like I said that you learned way back in elementary school. So if I take 3 and I want to divide it into 42, we would write this as 3 goes into 4 once. So I'm going to put a 1 up here. And then the process is that we do 1 times 3 gives me 3. And then we subtracted that term. Okay, so now we've got 4 minus 3 gives me 1. And then the next step was we brought down the 2. So now we want to take 3 divided by 12. We want to see how many times 3 goes into 12. It turns out that 3 divides into 12 4 times. So now our process is that we take 4 times 3 is 12. And again, we subtract that value, so giving us 0. If we end up with a 0, that means that 3 divides evenly into 42. Therefore, 3 is a factor. Okay, and I did the long way there because again, you're going to see some of these ideas showing up when we do long division with polynomials. Let's go ahead and do this example where we've got 5 divided by 42. So first thing we want to do, does 5 go into 4? It does not. So then we take 5 divided by the entire number of 42. Turns out that 5 goes into 42 8 times evenly. So now our process is that we do 8 times 5 is 40. And now we subtract that. So 42 minus the 40 leaves us with 2. This tells me that 2 is my remainder. Okay, so that means that we have a remainder of 2. Since the remainder is not 0, that means that 5 is not a factor. Okay, notice up here in my list, 5 was not written because 5 does not divide evenly into 42. Okay, so some of these ideas are going to show up when I talk about long division. Okay, so here, when we do division of polynomials, we're given a polynomial p of x and d of x cannot be equal to 0. There exists unique polynomials, q and r, such that we can write it like this. So d of x is the divisor, multiplied by our quotient plus the remainder, that's equal to our original function. Okay, in other words, it's this idea, this one down here. So the dividend equals divisor multiplied by the quotient plus the remainder. This right here is another way to write our solution. So let's practice writing these solutions with what we did up here. So we could say that the dividend is 42 divided by our divisor, which in this first problem is 3. That's equal to our quotient, which is our answer, of 14 plus a remainder of 0 divided by the divisor. Okay, we could write that same thing right over here. So this would be 42 divided by 5 equals our quotient, which was 8, plus a remainder of 2 over 5. Okay, the second way is to write it as dividend equals divisor times quotient plus the remainder. So here that would look like 42 equals 3 is our divisor, 14 is our quotient, plus a remainder of 0. So this expression is true. Okay, over here we can do the same thing. Another way to write our answer is to say 42 equals 5 times 8 plus 2. Notice that that equation is true. 5 times 8 gives me 40, plus the 2 gives me the 42. Okay, so we can write our answer in several ways. Alright, let's get into some examples. So here we want to divide x plus 4 into this polynomial, and we're going to practice writing our answer in the two ways listed above. Okay, so x plus 4 is our divisor, and we're going to divide it into x to the 4th plus 4x cubed plus 2x squared plus 9x plus 4. Okay, so a lot of the ideas that we did up here, the process is going to show up down here. Okay, so I'm going to take this x and I'm going to see how many times it divides, or I'm going to take x to the 4th and I'm going to divide it by x. That's a better way to say it. If you want, you can do that off to the side. Actually, I'll do it over here. So we're taking x to the 4th and we're dividing it by x. Well, when we do that, you can see that this reduces to x cubed. So that means that our first part of our quotient is going to be x cubed. So now I'm going to take this x cubed, multiply it by both of these terms, and then subtract it. So x cubed times x gives me x to the 4th. X cubed times 4 gives me 4x cubed. Notice that I'm lining it up underneath the like terms. So here's x to the 4th, I put x to the 4th here, x cubed is here, so I put x cubed here. Okay, well just like up here, we subtracted that 3. So down here, we're going to subtract these terms. So there's the subtraction sign, and then I'm going to subtract that term as well. Okay, well x to the 4th minus x to the 4th is 0. 4x cubed minus 4x cubed is also 0. Okay, and that doesn't always happen, but in this case it did. Okay, and then I'm going to go ahead and bring down the next term. And because we have two terms here, that means when I multiply it, I'm going to end up with two terms, so I'm actually going to bring down the 9x as well. Okay, so now we're going to take x and divide it into 2x squared. So if you need to, you can do that off to the side. 2x squared divided by x gives me 2x. So that's the next term in our quotient. Okay, so if I take, now I'm going to do just what we did up here. We took 4 times 3 and got the 12, and then we subtracted it. So we're going to do the same thing. 2x times this expression gives me 2x squared, and then 2x times 4 gives me the 8x. And again, we are subtracting those terms. Okay, well 2x squared minus 2x squared gives me 0. 9x minus 8x gives me 1x. Okay, and then I'm going to go ahead and bring down this 4, and we do the process one more time. So x divided by x, you can see, again, we can just do that off to the side. So x divided by x, that gives me 1, so that's the next term in my quotient. So now I'm going to take 1 times x to get x, 1 times 4 to get 4. Okay, and I'm going to say this one more time because so many times I see students forget to do this step. Just like up here, we subtracted the 3. And then down here, we didn't just write 12, we subtracted that 12. So we're doing the same thing down here. We're going to subtract the x, and we're going to subtract the 4. Both of those reduce to 0. Okay, so because we have a remainder of 0, that means that x plus 4 divides evenly into this term right here. Okay, Okay, what we want to do is we want to write our answer in the two ways listed above. Okay, so the first way, we would write it as our dividend, which is the x to the fourth, plus 4x cubed, plus 2x squared, plus 9x plus 4, all divided by the divisor, which is x plus 4, equals the quotient x cubed plus 2x plus 1 plus our remainder. So we could write that as 0 over x plus 4. Okay, if you wanted to eliminate that remainder, that's fine. Okay, and then part B is that we're going to write our dividend. So x to the fourth plus 4x cubed plus 2x squared plus 9x plus 4 equals our divisor multiplied by our quotient. Okay, plus a remainder of 0. Okay, so both of these are equivalent to each other. So here, if I add these two together, that would give me this term over here. And then this right here, if I multiplied these two together and added 0, that would give me my original value back. Okay, just like up here, if I multiplied these plus the remainder, that gave me my original value back. Okay, what we're going to move on to next is what it means when we have this divided by 0. So again, I want to keep connecting it to what you know. When we divided 3 into 42, we ended up with 0, which means that 3 was a factor. When we divided and we did not get a 0, that meant that 5 is not a factor. So how that connects down here is that here we have a 0, which means that x plus 4 is a factor. So when it's a factor, it means that it divides evenly into this polynomial. Let's go ahead and do another example. Okay, so here we're going to determine if x plus 1 is a factor of negative 3x cubed minus x minus 5. Since we're determining if it's a factor, that means that we want our remainder to be 0. If it's 0, then it's a factor. If it's not 0, not a factor. Alright, so we've got x plus 1, and we're going to divide it into this. So we start off with negative 3x cubed. Notice that when we look at the powers, we've got a 3 here, this is a 1. We're missing that we're missing that x squared. So we need to place that in here as a placeholder. So we get 0x squared minus x to the first, if you want to put that you can, minus 5. Okay, so notice that now our power is reduced by 1 every time. So 3, 2, 1, and then we have our constant. We need that placeholder there. Okay, so make sure you don't forget that. Always check for that. Alright, so now we're going to do our long division. So we're going to take x and divide it into this term right here. And again, if you need to, you can do that off to the side. So negative 3x cubed divided by x, that gives me negative 3x squared. So that's the first term in my quotient. So I'm going to take negative 3x squared, multiply it by x, which gives me negative 3x cubed. And now negative 3x squared times 1 gives me negative 3x squared. Okay, and don't forget, so here's where that mistake happens, where here students already see that negative, but don't forget, we have to subtract these terms. Well, when we subtract a negative, that's the same as adding. So here we're going to subtract this negative, which means that we're technically adding it. So negative 3x cubed plus 3x cubed gives me 0. And then 0x squared plus 3x squared gives me 3x squared. I'm going to go ahead and bring down this negative x. Okay, and again, we're going to take x divided into the 3x squared, which that reduces to 3x. Okay, so that's the second term in my quotient. Okay, so now 3x times x gives me 3x squared. 3x times 1 gives me 3x. And again, we have to subtract both of these terms. So 3x squared minus 3x squared gives me 0. negative x minus 3x gives us a negative 4x. And now we bring down that last term of negative 5. Okay, so then we're going to take x divided into negative 4x, which gives us a negative 4. So that's the last term. Oops. Ignore that. Okay, so that gives me negative 4. So negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. And again, we have to subtract these terms. Subtracting a negative makes that positive. And over here, subtracting a negative makes that positive. 4x, negative 4x plus 4x is 0. Negative 5 plus 4 gives me a negative 1. So now we're done with our long division. So the question was, determine if this is a factor. In order to be a factor, the remainder must be 0. So since the remainder is not a 0, then x plus 1 is not a factor. Okay, so that answers our question. Again, this has to be 0 in order for x plus 1 to be a factor. Okay, let's go ahead and do this example here. So we've got x squared plus 4. Again, we want to determine if this is a factor of this polynomial. Notice that our power is reduced down by 1. So we've got 4, 3, 2, 1, and then our constant. So we don't need a placeholder like we did up here because we were missing that x squared. Okay, so now we're going to do the division. The process is the exact same. So we're going to take x squared divided into 3x to the 4th. So that gives me 3x squared. That's the first term in my quotient. Okay, so now 3x squared times x squared gives me 3x to the 4th. And 3x squared times 4 gives me 12x squared. Notice that this next term right here is x cubed. And when we multiplied this, we end up with x squared. So I want to write that 12x squared underneath the like terms. Okay, so again, notice that I jumped because 3x squared times 4 gave me 12x squared. I want to line up my like terms. Okay, so now we want to subtract those terms. So 3x to the 4th minus 3x to the 4th, that gives me 0. This just follows down, so 2x cubed. 13x squared minus 12x squared gives me 1x squared. And then I'm going to go ahead and bring down this 8x. I've seen some people when they do division with factors that are not linear, meaning that the power is not 1, they write down all the terms. They just bring everything down every time. And that's okay, you can do that if you want. Okay, so now we're going to take this as our first term now. So we've got 2x cubed. We want to divide that by this leading term up here, the x squared. So doing that, this gives me 2x. So that's the next term in my quotient. So 2x times x squared gives me 2x cubed. 2x times 4 gives me 8x. Again, I want to line up my like terms. Okay, and so we subtract those terms, leaving us, that becomes 0. This leaves us with x squared. This becomes 0. And then we have our plus 4 at the end. Okay, so now we're going to take x, the leading term here, which is x squared, and divide it into this right here. So x squared divided by x squared, that's equal to 1. So that means that this term is going to be plus 1. So 1 times x squared is x squared. 1 times 4 is 4. And make sure you subtract those. Okay, so that becomes 0, and then this becomes 0. Okay, so that's it for completing the long division. Now let's make sure we answer the question. It says determine if this divides evenly into this, meaning does this x squared plus 4, is that a factor of this polynomial? The answer is yes, because we have a remainder of 0. So since the remainder is 0, then x squared plus 4 is a factor. Alright, so that's it for long division. I'm going to show you the synthetic division. Before we do that, I want to make sure that we understand some terminology. So when we have x minus r is a factor of f of x, so in this case, let's use this as an example. Or actually, let's go back to this one. Okay, so this example right here, we knew that x plus 4 was a factor of this polynomial because we have a 0 as a remainder. Okay, so when I had x plus 4, this is known as a factor. Okay, when we set it equal to 0 and solve, okay, so if I were to take x plus 4, I'm going to do that down here, and set it equal to 0, we can solve for x by subtracting 4 from both sides. So this has several terms related to it. So when we say x equals negative 4, that means that negative 4 is a root of our function. We could also say that negative 4 is a 0 of our function. And then later when we start to graph, that x-intercept is the same as our root and our 0. So root, 0, and x-intercept, those all mean the same thing, just in slightly different context, but the idea is the same. Here we say x equals negative 4 is the root, negative 4 is the 0, and then we could write that as a point. Negative 4, 0 is the x-intercept. Okay, so, and a lot of times these words get used interchangeably, root, 0, and x-intercept. Alright, so now that we have that, let's move on to synthetic division. So we're going to use synthetic division to solve these two problems. Notice they're the same exact problems as what we did before. So here we've got x plus 4 divided into this expression. Okay, so that was this very first long division problem. Okay, when we do synthetic division, the x plus 4, that's written as a factor. When we do synthetic division, we want to use the 0. So that would be x equals negative 4. So that is the root, which means the 0 is negative 4. Okay, when we do synthetic division, we want to use the 0, and I'll show you how to set it up. So we're going to do negative 4, and then we put a little box or a little half box around it. And then looking at this polynomial, we only write the coefficients, meaning the numbers in front of our x's. So this is 1, then we have 4, 2, 9, and 4. Leave some space and then put a line. So this is our setup for synthetic division. Again, here x plus 4 is written in a factor form. So we use the 0 of that. Okay, well, now that we've got these numbers, the process for solving synthetic division is that we bring down the 1. We do 1 times negative 4. So then we write that underneath the next term. So 4 minus 4 is 0. So we just add our columns. Now we do 0 times negative 4, which is 0. Be careful, a lot of times students want to say that 0 times negative 4 is negative 4, but it's not. 0 times any number is still 0. So we add the column, that gives me 2. 2 multiplied by negative 4 gives me negative 8. Add our column, gives me a positive 1. 1 times negative 4 gives me negative 4, which is 0. So this process is our synthetic division. And then how we interpret this result is, notice that we started with x to the 4th. So our solution starts with 1 less power. So that means that this is x cubed, 1x cubed, plus 0x squared. So just using the coefficients here, plus 2 x plus constant, and then this 0 is the remainder. Okay, so I'll say that one more time. So here we started with x to the fourth. Our solution is that we reduce it by 1 power. So this becomes x cubed. This next number is the coefficient for x squared. This is the coefficient for x. And then this last one is our constant. And then this very last number becomes our remainder. Okay, so notice when I compare it to this problem, let me scoot down just a little bit. Okay, notice that our result is the same. We have x cubed, here we have x cubed. Our next term was 2x, here we have 2x because that's 0, and then we have plus 1. Okay, so this work on synthetic division takes the place of all of this work over here. Okay, so it makes it just a little bit faster. Let's go ahead and do one more example. Okay, so here we've got x plus 1. That's our potential factor. That means that x equals -1 is the root. Therefore, -1 is the 0. Okay, when we do synthetic division, we use the 0. So this becomes -1. I'm going to put the little half box around it. And then again, we're going to use the coefficients of this polynomial. So this is really -3x cubed plus 0x squared, don't forget that placeholder, minus x minus 5. So we just write the coefficients in front. So -3, 0, -1, -5. Okay, our process is that we're going to bring down the -3. Now we're going to take -3 times -1 to give me a +3. We add our column, which means we get 3. 3 times -1 is -3. Add our column gives me -4. -4 times -1 gives me +4. Adding the column gives me -1. Okay, so to interpret this answer, here we started with x cubed. So this first number down here is the coefficient to 1 less power. So this is a coefficient of -3. Since this is x cubed, that means this is going to be x squared plus 3x minus 4, and then this -1 is the remainder. Okay, notice, let's go to that problem. Okay, so here was that problem that we just did. Okay, so this is the long division. This right here is synthetic division. Notice our answer is the same. -3x squared plus 3x minus 4, and then we had a remainder of -1. Okay, so this step right here is much more condensed than writing all this. So synthetic division just helps save us some time and less errors are made. Okay, so we can still do the same idea that if this remainder is 0, that means that x plus 4 is a factor. Here, if our remainder is not 0, that means that x plus 1 is not a factor. Okay, so that's your synthetic division. Some things to note with synthetic division is that it can only be used when the divisor is linear. So notice here, this x plus 1, the power on the x is just 1, meaning it's linear. Up here, this x plus 4 has a power of 1, which means that it's linear. If we look at the third example that we did, this x squared plus 4 divided into this polynomial, we could not do synthetic division with this because this right here has a power of 2, meaning it's not a linear factor. Okay, so make sure that you pay attention to that. So Synthetic division can only be used when the divisor is linear. When doing synthetic division, we always use the 0, just like we did up here. So these were the zeros. When using long division, then we use the factor. So like back here, here was our long division. We used the factor. All right, so almost done. We just have two theorems that I want to talk about. So the remainder theorem and the factor theorem. Okay, and then this will give us some practice with synthetic division again. Okay, so here we've got this polynomial, 2x cubed minus 7x plus 33. Notice that the x squared is missing, so let's put that in for a placeholder. So 2x cubed plus 0x squared minus 7x plus 33. Okay, we want to determine if x minus 2 is a factor. Okay, so since this is the factor, we want to use the 0 if we're going to do synthetic division. So since x plus 2 is the factor, that means that our 0 is negative 2. Okay, and then now we just write the coefficients of these numbers. So we get 2, 0, negative 7, 33. Okay, I'm going to go ahead and do synthetic division. So bring down the 2. 2 times negative 2 gives me negative 4. Adding the column gives me negative 4. Negative 4 times negative 2 gives me positive 8. Adding the column gives me 1. 1 times negative 2 gives me negative 2. Adding the column gives me 31. Okay, so we want to determine if x plus 2 is a factor. So since the remainder is not 0, then x plus 2 is not a factor. Okay, let's go ahead and do part B. It says determine if x plus 3 is a factor of this. So again, they're giving us it in the factor, so we want to use the 0, which is going to be negative 3. And then we just write our coefficients. So 2, 0, negative 7, 33. Bringing this down, we get 2 down here. Multiply 2 times negative 3 gives me negative 6. Adding my column gives me negative 6. Negative 6 times negative 3 gives me positive 18. Add the column gives me 11. 11 times negative 3 is negative 33. And then we end up with 0 when we add our column. Okay, so since the remainder is 0, then x plus 3 is a factor. Okay, so there's two more examples of that. And then now what we want to do is we want to evaluate f of negative 2, which means that I'm going to take negative 2 and plug it into my original equation. So this is part C. So f of negative 2 means that I'm going to take negative 2, and anywhere I see an x, I'm going to plug it in. So we get 2 times negative 2 cubed minus 7 times negative 2 plus 33. Multiplying this all out, we get 2 times a negative 8 plus a 14 plus 33 gives me negative 16 plus 14 plus 33 gives me a positive 31. Notice that it's the same result right here. Okay, let's go ahead and do it for this one. Let's evaluate part D. So f of negative 3 means that I'm going to plug negative 3 in anywhere I see an x in my original function. So 2 times negative 3 cubed minus 7 times negative 3 plus 33. This gives me 2 times negative 27 plus 21 plus 33. That gives me a negative 54 plus 21 plus 33, which that results in 0. Notice that we ended up with the same result over here. Okay, and so then that just gives us our two theorems. So if a polynomial p of x is divided by x minus c, the remainder is equal to p of c. So here's the synthetic division. There is our remainder, which means that if we evaluate the function at that 0, we get the same result. Same thing over here. We divided by x plus 3 using synthetic division. Here's our remainder. That means that if we evaluate the function at that 0, we get the output or the evaluation of this expression. Okay, and then the factor theorem, we've been talking about this all along. So if the result is 0, meaning this result right here, if that's 0, then this is a factor. Okay, if it's not 0, like in this case, we ended up with something that was not a 0. Or actually, let me come down here and let me rephrase it the way they have it written. So if x minus c is a factor, then the result is 0. Okay. All right, so that is it for this lesson.